Hi, this lesson is about solving quadratic equations. So there are four methods that we're going to focus on in this module. We're going to be solving by factoring, solving by the square root method. We'll use the quadratic equation formula and a method called completing the square. In this lesson, we're going to focus on the first two, solving by factoring and solving by the square root method. We'll learn the other two methods in another lesson. So remember, when you want to solve a quadratic equation by factoring, you want it first to be in what we call standard form. And standard form looks like this in general, where you have your terms separated by pluses and minuses set equal to 0. A, B, and C are real numbers where A is the coefficient of x squared, B is the coefficient of x, and C is the constant. As long as you have this first term, ax squared, then it's considered to be a quadratic equation. So in other words, the bx term could be missing, the constant can be missing, both the bx and the constant could be missing, but you need to have that term with a second, showing that it's a second degree polynomial, the 2 as the exponent, for it to be considered a quadratic. All right, so the first few examples we're going to be solving by factoring. So remember, if it's not in this form, you have to put it in that form first. So our first example is not in that form. Here I have a product and then a constant on the other side of 7. So I needed to put it in standard form. So first distribute the x. So I get x squared minus 6. And then I also need to subtract 7 so that it's on the left side. So I get x squared minus 6x minus 7 equals 0. So that second line is in standard form. So now we're ready to factor. So I need two numbers that multiply together to give me negative 7. But when I add them, I get negative 6. So that's going to be negative 7 and positive 1. So there are my factors. Then set each factor equal to 0, and you get two solutions. X is equal to 7, and x is equal to negative 1. So you will always get two solutions with a quadratic equation. So second degree polynomials, the degree tells you how many solutions to expect. The only exception is if you happen to get the same solution twice. So in other words, the same factor twice, and then you would only have one solution. Here's another example. Example 2. I have 2 times a minus 3 equals 3a squared plus 13a. Okay, so this appears to be a quadratic equation as well because of this term, but it's definitely not in standard form. So first thing I'm going to do is distribute on the left. So I get my second line here, 2a minus 6 equals 3a squared plus 13a. Then I need to subtract 2a and add 6 so that the left side is equal to 0. So I like to keep the first term positive, so I'm going to leave the 3a squared on the right. So when I subtract 2a and add 6, you get this equation, 3a squared plus 11a plus 6. So this is a second degree polynomial on the right with a leading coefficient of 3. So with a quadratic in this form, there are two ways to factor this, as we've talked about in previous lessons. You can either factor it by the trial and error method or by the AC method. So let's talk about trial and error first. So trial and error is exactly what it sounds like. You have to guess and check different combinations of numbers, but it's a controlled guess and check because there's only one way to get 3a squared in the first position. And that's with a 3a and an a, so that's why that goes here. 3 is a prime number, so you don't have a lot of options. And then you need two numbers that will give you 6 in the last position. And so we know that 6 could be 1 and 6 or 2 and 3. Now, which pair you use in the position of it depends on what your middle term is. And remember, your middle term is 11. So if you put 3 in the last position, the 3a and the 3 gives me 9a, and put 2 here, and that gives you 2a as your inner term. 9a plus 2a gives me 11a. So that's how you know it works. Then set each factor equal to 0, like you see here, and you get, again, two solutions. A is negative 2/3, and a is negative 3. So it's okay to have fractions and decimals as solutions, not just integers. Okay, so same problem, but we'll do it by AC method. You really just need to be good at one of the methods, either trial and error or AC method. You don't have to do it twice. That's totally unnecessary. So AC means that you multiply the A and the C, and that, remember that A is the leading coefficient of A squared and the C is the constant. So I'm multiplying 3 and 6. That gives me 18. And then I want to figure out two numbers that multiply together to give me 18, but when I add them, I get 11. And again, why 11? Because that's your middle term. So the two numbers that will work are 9 and 2, because 9 times 2 is 18, but 9 plus 2 is 11. Okay, so then you use the 9 and the 2 to rewrite this equation in standard form, but you're going to expand the 11a. So I'm going to write 11a as 9a plus 2a, because that is equal to 11a. So there's our equation with 4 terms. And then you're going to factor by grouping here. So the first pair of terms have a common factor, a GCF of 3a, leaving me with 3a times a plus 3. The second two have a common factor of 2, so that leaves me with 2 times a plus 3. And then the a plus 3 is a common factor of this line, so that goes first. And then you write the other factor as the other two terms that are left, the 3a plus 2. So again, that leaves me with the same two factors that I got with trial and error. They're just written in a different order, but it results in the same solutions, negative 3 and negative 2/3. And you should get the same answers regardless of the method that you use. Okay, so now we're going to talk about solving by the square root method. So with the square root method, you do not want your equation to be in standard form. It simply can't be done in this format. So in fact, what you want is you want the x squared term on one side and the constant on the other, but it has to be in a very specific format. So it can't just be any x squared term. So let me show you a very simple example. So here we have x squared minus 25 equals 0. So as I mentioned, this is in standard form, but that's not what you want with the square root method. So first I'm going to add 25, and then I'm going to take the square root of both sides of the equation. That's why it's called the square root method. Now the square root of x squared is x, but the square root of 25, well, that's either plus or minus 5, either positive 5 or negative 5. And that's because 5 times 5 is 25, but so is negative 5 times negative 5 is also equal to 25. So when you use the square root method to solve an equation, you have to remember to put this in front of your answer. That means plus or minus 5, positive or negative 5. But this particular equation could have been solved by factoring. So if you're asked to solve and you're not told what method to use, you can solve it any way that you'd like, that works. This one is the difference of perfect squares. So when you factor it, you'll get x plus 5 and x minus 5, resulting in the same two solutions, positive 5 and negative 5. Okay. But not everything is factorable, so that's why we're learning other methods, such as square root method, and such as completing the square and the quadratic formula in future lessons. All right, so here's another one. Example 4, this is x plus 6, that binomial is squared, minus 9 equals 0. So this is certainly not in standard form, but this makes it a really great candidate for the square root method because my x expression, which is x plus 6, is contained in this parentheses raised to the second power. So that's a perfect expression to take the square root of. But before I do that, I need to get my constant over on the other side. So that's what you see here. You add 9 first. Then you take the square root on the left and on the right. And the square root of x plus 6 squared, well, that just leaves me with the radicand, x plus 6. And here again, the square root of 9, don't forget, put not just 3, it's plus or minus 3. Then I subtract 6 in order to get the x alone, and you get that x is negative 6 plus or minus 3. But you definitely don't want to leave your answer like that, because you can add and subtract negative 6 with either 3 or negative 3. So I expanded them here. Negative 6 plus 3, well, that's equal to negative 3. And negative 6 minus 3, well, that's equal to negative 9. So again, 2 solutions. So let's move on to another one. So I have z plus 4 squared equals 72. So this one is again perfect for the square root method, because this expression on the left is already contained in a nice binomial raised to the second power. That's what we want to take the square root of. The 72, or the constant, is already on the right side, so we're just going to leave it exactly where it is. So we go straight to using the square root method. So I take the square root of both sides. On the left side, that just becomes z plus 4. On the right side, I have to simplify the 72, because 72 can get rewritten as 36 times 2. And we like 36 and 2 because 36 is a perfect square. So on this line, I took the square root of 36. That's 6. That comes out. Don't forget, put a plus or minus in front. So the square root of 72 is plus or minus 6 root 2. Okay, but I'm not quite done, because I have to solve for z. So you have to subtract 4 from both sides. So you get that z is negative 4 plus or minus 6 root 2, which again represents 2 solutions. So if your homework asks you to write it as a comma separated list, you would separate the plus or minus. So here you have z is negative 4 minus 6 root 2. So that would be the smaller of the 2 solutions. And then the other one is negative 4 plus 6 root 2. So you just split these up between the plus and the minus. So a problem like this, where you end up with a radical in your answer, that's, remember, numbers with radicals that can't be broken down more than, like here, for example, square root 2, you would not be able to factor this. So if you don't get integers or fractions as an answer, then it's not factorable. So at this point, this would be your only option to solve a quadratic equation like this. You'll have more options in future lessons. All right, so here's another example. I have 2, y minus 2 squared minus 98 equals 0. So similar to a couple problems back, first I want to move the constant over to the right. So that's my second line. I have 2, y minus 2 squared equals 98. And then I divide by 2. To get that y minus 2 term alone. So that's what you see here. Divide both sides by 2. So on the left side, the 2's cancel. So that's what you see here. And on the right side, 98 divided by 2 is 49. So now I'm ready to take the square root of both sides. So that's what you see here. And then the square root of 49 is plus or minus 7. So I have y minus 2 equals plus or minus 7. Then get y alone, which means add 2 to both sides. So you get y is equal to 2 plus or minus 7. So similar to a problem I did earlier, you don't want to leave it like this. You can certainly add 2 and 7 and subtract 2 and 7. So that's what you see here below. I subtracted it first and then I added it. So I get 2 solutions, negative 5 and 9. So as I mentioned, when you get answers that are integers or fractions, you could have factored it. So I want to show you what would happen if you chose to factor it. So if you chose to factor this instead, and you really don't know if it's going to be factorable when it looks like this. So sometimes you just have to try it and see how far you can go. So here, first I expanded, which means I squared this first. Because remember, if I want to solve this by factoring, I need it to be in standard form. All of my terms on one side with pluses and minuses. In between, the whole thing set equal to 0. So that part is good. It's already set equal to 0, but on the left side, it doesn't quite look right. So I squared y minus 2 squared, giving me this. Then I distributed the 2. So that's this line here. Then I combined the 8 minus 98, so that's my third line, so that becomes 2y squared minus 8y minus 90 equals 0. Then I factored out a 2, because all of those have a common factor of 2. So I'm left with 2 times y squared minus 4y minus 45. So the trinomial is factorable. So here, two numbers that will give me a product of negative 45 and a sum of negative 4 would be negative 9 and positive 5. So the two variable factors get set equal to 0, and you get y is 9 and y is negative 5. So the same answers I got before with the square root method. Okay, so again, if you're not told how to solve a quadratic equation, you can try different options. But either way, you should get the same result. Okay, so that's your lesson. Give the homework a try.